Hello guys, how are you? Hope you are doing well. Welcome to our channel Last Minute Pharma. Okay, today we are going to discuss about a new chapter, new beginning. After a long run of general pharmacology, we are back here with unit 2, that is the autonomic nervous system. So yeah, I have got many issues with the timing that we are taking lengthy videos. Don't mind, it's just for the starting phase, because starting general pharmacology, which is there, it's a vast topic, not much important for your examination, but a very vast topic and very basic concepts. So for the basic concepts which are there, we have taken some more time, but now we will be taking like around maximum 15 to 30 minutes of per session. We won't be going more, we won't be exceeding more than 30 minutes. Okay, so today we are going to discuss about the autonomic nervous system or autonomic pharmacology. Okay, this chapter which is there, majority of the students fail to understand because the basics are not clear. So in this session we'll be discussing about the basics first. Understand what is cholinergic, what is anticholinergic, what is adrenergic, what is non-adrenergic. All this classification will understand, okay, and we'll take it in a very easy and smooth way. And one more thing is that for exam point of view, only selected topics are there. Okay, in exam point of view, you only have to understand certain topics. But many of the students, what they do is in the way of learning extra, they learn so much that at the finally the basic question or basic understanding is going bad. That is nothing but they don't know difference between what is cholinergic, what is adrenergic. Okay, so to clarify that, let us understand the basic first, and then we will move on with the advanced topics. So before studying the autonomic pharmacology, I want you to understand the clear understanding of your nervous system. The nervous system which is there, we are mainly classifying it into two types. One is your central nervous system, other one is peripheral nervous system. So when I'm talking about the central nervous system, that means here I'm going to mainly include the brain and the spinal cord. I'm going to mainly include the brain and the spinal cord. But when I talk about the peripheral nervous system, I'm going to classify my peripheral nervous system into your autonomic nervous system and somatic nervous system. Simple understanding you should have between autonomic and somatic is that autonomic nervous system which is there, it controls majority of the involuntary movements. This autonomic nervous system which is there, it is going to majorly control over the involuntary movements. That means majority of these nervous tissues are attached to the smooth muscles, because smooth muscles we're not able to control, right? Majority of the smooth muscles, we talk about the GI tract, we talk about the eyes, like if we talk about ciliary muscles, all these are smooth muscles which are not going to control. So this autonomic nervous system will include your involuntary function. Okay, is it clear? So those nervous system or the nervous system which is involved in controlling the involuntary function of the body or automatic, right? That's why we say it as it's involuntary and automatically it happens. That's why we say it as autonomic nervous system. Now, let us try to understand what is somatic nervous system. Somatic nervous system, remember S for somatic, S for skeletal muscles. Okay, so these nervous tissues or nervous system which is there, it is majorly involved with nerves which are going to attach to the skeletal muscle. That means those nervous system which is responsible for the voluntary activity of the body, for the voluntary control of the body. Okay, so what we divided? We divided a peripheral nervous system into your autonomic and somatic nervous system. In your somatic nervous system, it is nothing but you are going to have a voluntary action. The nervous system which is going to be involved in controlling the voluntary action. So when I'm talking voluntary action, what is it? For example, I'm talking, I'm able to move my hands, I'm able to move my legs. So what is all that? Voluntary, right? And this voluntary action means who is controlling this? Who is going to control this voluntary action? That is skeletal muscles, right? Similarly, in contrast to your somatic nervous system, you are going to have the autonomic nervous system which is going to control majority of the involuntary movements, which is going to control majority of the involuntary movement. Now this involuntary movement, the autonomic nervous system, is divided into sympathetic nervous system and parasympathetic nervous system. Okay, so I hope the classification of nervous system is clear and we detailedly understand now what is the sympathetic nervous system and parasympathetic nervous system. Okay, so it's a very basic analogy of your class 10th only. You will have studied it. Okay, in your chapter, that's like control and coordination you study, right? Where you're going to study about the adrenal gland, right? Which is there about the kidney, renal caps, adrenal gland. So whenever you are there in a stressful condition, when the body is in an active state, or when the body is in a stress condition, okay, so which type of nervous system is going to get activated? Obviously, that is the sympathetic nervous system. That is going to be the sympathetic nervous system. For example, you are excited, you want to do something, you are really excited. So which kind of hormones are going to get secreted? Obviously, it's the hormones that is nothing but adrenaline. You're going to have the adrenaline rush. So this adrenaline which is there, this adrenaline hormone which is there, it will act as a neurotransmitter for the sympathetic nervous system. It will act as a neurotransmitter for the sympathetic nervous system and will activate the sympathetic activities. What are the sympathetic activities? Sympathetic activities can be like it will increase the blood pressure, increase the heart rate, increase the SN node activity. That means it's going to overall increase the cardiovascular function. Right? Have a basic understanding now. See, for example, you're in a stressful condition or you're in an excited state. So what is going to happen? You're going to move, right? That means you need energy. So for the energy to be there, what you need? Blood, because blood has oxygen, it has glucose, it has to be transported to the cells so that it can provide the energy. So for that, what the body has to do? Body has to increase the adrenaline concentration. So because of which your heart will function more efficient, or if your heart will function, it will get activated. The blood pressure will increase, the heart rate will increase. That's why you see, when you're getting scared or when you're excited, your heart rate usually increases. Okay, for example, when you're going for a stage, when you're going to open mic and you're going for a stage, what happens to you? Your heartbeat will increase, right? Your heart rate will increase. So that is what is nothing but your sympathetic nervous system. And who is controlling this? Adrenaline hormone. Okay, or adrenaline, which is there over here, is going to act as a neurotransmitter. Now, second thing, the exocrine gland activity. Exocrine gland activity is going to decrease. Now, for example, let's say I say thing, you went on the stage. So first thing, what you feel? Your mouth will become dry, right? Your mouth which is there is going to become dry. Why? Because saliva will not be secreted, or the exocrine activity which is there of the salivary gland, that will be decreased. That's why you are going to feel mouth dryness. Now what are the things you can see? For example, you will have heard, right, when the people are in stress, okay, when the people are going in continuous stress, they will have a common issue of indigestion. Now why this indigestion is there? Because when the body is in stress, the GI which is there, the GI tract which is there, or the GI secretions which are there, gastric secretion, intestinal secretion, pancreatic secretion, it won't be secreted. So because of which, what is going to happen? Obviously indigestion is going to happen, or the food which is here there, which you are going to eat, will not be getting digested. Okay, next thing, the urinary secretion, or the urinary secretion which is there when you're in imagine you're in an excited state or when you're scared. So usually what is happening? Urinary secretion which is there, that is going to decrease. So I hope it is clear. And clearly, in contrast, you're having the parasympathetic activity. Imagine, see, sympathetic nervous system which is there, okay, this is going to happen when you're going to be in a excited state. Okay, when you're going to be in a excited state. This is also called as fight and flight. Okay, fight and flight. For example, you see a snake, you have two options. Either you run away or you go fight against the snake, right? So obviously, majority of the obviously are going to run away. But you need what you need. Either you're fighting or you're running. But what is the main thing you require? Energy. So how do you get this energy? By increasing the sympathetic activity, by increasing the sympathetic outflow, you can say, or by increasing the sympathetic activity or sympathetic nervous system activity. Now, in contrast, you're having parasympathetic nervous system, which is mainly involved in the rest and digestion, which is going to mainly be involved in the rest and digestion. So this nervous system will get activated when you are resting, when your body is in a non-excited state, when you're relaxing, when you're calming down. That is when your digestion is going to happen, right? So when you're in stress, your GI secretions will not be there. So when you're relaxed, for example, you're sitting on a sofa, you're watching TV, or you're relaxed completely, you're going to sleep. So what is going to happen over there? The cardiovascular. Do you need energy now? No. You need maximum energy, or you need maximum blood to go and help in the digestion process. That's why it's called as rest and digest, right? So what is going to happen? Your cardiovascular function which is there, that is going to decrease. Your heart rate will decrease, your blood pressure will decrease. That's what happens when you're sleeping, right? Your heart pressure and your blood pressure and your heart rate will slowly decline, right? And later if we talk about the exocrine gland secretion, okay, exocrine gland secretion, that means salivary gland which is there, that will be increasing its activity. The lacrimal gland which is there will be increasing its activity, especially GI secretions are going to happen, and the urinary secretion which is there in the parasympathetic activity. Okay, it's a very this thing, right? When you're in a stressful condition, even if you want to urinate, you cannot go for urination. You won't get urination. But when you're relaxed and calm state, and that's the only time when the depressor muscles are going to relax, and that time you'll get the urinary secretion. So this is the basic understanding which you're supposed to have between sympathetic nervous system and parasympathetic nervous system. Now you might be thinking, why am I boring you with these common basic things? Because this is what I'm going to connect now with the cholinergic and anticholinergic. Okay, so let's try to understand about the things. See, now here when I talk about your sympathetic nervous system, okay, So those drugs which are going to activate the sympathetic nervous system, okay, those drugs which are going to activate your sympathetic nervous system, these are called as adrenergic drugs. These are called as adrenergic drugs. Okay, they are going to stimulate, okay, they are going to stimulate your adrenaline. Okay, these drugs which are there, they are going to stimulate your adrenaline. Similarly, which are going to inhibit this adrenaline, they are called as your non-adrenergic drug. Okay, so those drugs which are going to stimulate the sympathetic activity, that drugs will called as adrenergic drugs, and those drugs which are going to inhibit this adrenaline or which is going to inhibit the sympathetic activity, these are called as non-adrenergic drug. Similarly here also, if we talk about what is this parasympathetic activity, acetylcholine. So those drugs which are going to increase the activity of parasympathetic nervous system, okay, that we are going to call it as cholinergic drug. That we are going to call it as cholinergic drug. Now term cholinergic came from acetylcholine. Acetylcholine is a neurotransmitter which is going to be involved in your parasympathetic nervous system, and adrenaline is a neurotransmitter which is going to be involved in the sympathetic nervous system. So now acetylcholine which is there, it's going to act on the cholinergic drug. As cholinergic drugs are going to activate the acetylcholine, but whereas those drugs which are going to inhibit your acetylcholine secretion, they are called as your anticholinergic drugs. So if you understand these basic concepts, you will never get confused. What is adrenergic, what is non-adrenergic, what is cholinergic and anticholinergic. Now in this lecture, we will try to understand about the cholinergic transition. What is the how is this cholinergic secretion going to happen? How is how is it going to connect? Okay, let us try to understand about the cholinergic drugs before, and after this, slowly we are going to cover up all the ANS drugs. So in this way, we will simply try to understand what are the important questions which you have to focus on instead of simply just reading the books. Okay, let's start with it now. Okay, so now we are going to discuss about the synthesis and cholinergic transmission. Okay, how this cholinergic which is there, or acetylcholine which is there, is going to act on various parts of the body and then show you the parasympathetic activity. Okay, so as we discussed earlier, the cholinergic drugs we talk about or acetylcholine which we talk about, these are going to stimulate your parasympathetic activities. Okay, so before understanding what are the activities, we should understand how is this cholinergic transmission happening in the nervous system, or from where is this acetylcholine coming from. Okay, so first we are going to discuss in detail about the synthesis of acetylcholine. It's not much important for your examination point of view, but it will help you in making a strong base. Okay, so now over here, the acetylcholine which is there from the mitochondria, as you remember the Krebs cycle and everything, right? So from there you are going to get the acetyl-CoA. Okay, acetyl-CoA enzyme or acetyl-CoA which is there, this is going to come from the mitochondrial source. Then the choline which is there is going to come from external inside the nervous system, and acetyl-CoA plus acetylcholine, this is going to form your acetylcholine, which is going to be stored in the storage vesicles, which are going to be stored in nervous system, in the nerve cells in the form of the storage vesicle. Now, when this cholinergic neurons or when this acetylcholine is released from the body or released from the nervous system, it's going to go and bind with the cholinergic receptors. So there are different types of cholinergic receptors which are available based on where the location it is. Okay, from where the location. For example, if you talk about M2 is mainly present in the heart, right? If you talk about the M1, they're mainly present in the GI tract. So based on location, we are dividing the various cholinergic receptors. Okay, so before going under, we'll have a detailed discussion about cholinergic receptors also. But the transmission, you should understand that acetyl-CoA plus choline is going to form acetylcholine, which is supposed to be stored, which is going to be stored in the storage vesicles. Now, once this acetylcholine is released, it's going to go and bind with the cholinergic receptor. Now, one very important thing to understand that in the transmission, there is an enzyme which is called as acetylcholine esterase. It's called as acetylcholine esterase. This enzyme which is there, this is responsible for breaking down, say after the acetylcholine action is done, what will happen to acetylcholine? It has to degrade, right? This acetylcholine, after going and binding, this acetylcholine is going to degrade again, or it's going to break down again into acetyl group and the choline group. And this acetyl group this choline group which is there, this will be again used back by the nerve cell. Is it simple? Now here acetylcholine plus choline will form acetylcholine. Now after it's released, there's an enzyme which is called as acetylcholine esterase, which is going to break down this into acetyl plus choline. Now try to understand, just give a thought of it, that what will cholinergic drugs do on this synthesis, or what will this cholinergic drug help in promoting acetylcholine secretion? First thing is that directly acting cholinergic drugs, okay? So directly acting cholinergic drugs means what? As acetylcholine is there are different kinds of choline esters, so they are going to be directly available for the transmission or for this acetylcholine. For example, if we talk about direct esters, like acetylcholine when you are going to inject, it will directly go and bind to the cholinergic receptors which are going to be present in the body. These are called as direct. They are going to directly act on the body. But there is something called as indirectly acting cholinergic drugs. Now, what is indirectly acting cholinergic drugs? See, detailed classification will understand, but basic knowledge you should have that. Cholinergic drugs which are there, we are classifying it into direct and indirect. Okay, so direct drugs which are there, they're directly going to inject the drug, and this drug is going to go and bind to the cholinergic receptor. As simple as that. Like for example, acetylcholine is there. Like many other choline esters are there. Okay, so these are the drugs. But now if we talk about indirectly acting, how will these drugs act? These drugs are going to go and inhibit this acetylcholine esterase. These are going to be anti-acetylcholine esterase, or these drugs are going to go and inhibit this. So if you are inhibiting this acetylcholine esterase, what will happen? The degradation of acetyl and choline will not happen. So if degradation is not happening, what is going to happen? The concentration of acetylcholine in the nerves, if you talk about nerve transmission, in the synapse, is going to increase. So more the acetylcholine in the synapse, more the cholinergic activity is going to be there. So this is how the drugs which are there in the, see, they're very superficially I said, okay, this is how the drugs which are there are going to promote the cholinergic activity, or you can say about the parasympathetic activity. Is it clear? So this is about the synthesis of acetylcholine. Now one more thing you have to understand over here, this acetylcholine esterase, okay, there are two types. One is acetylcholine esterase, other one is butyrylcholine esterase. Okay, when I'm talking about acetylcholine esterase, it can be a 2-mark question. Acetylcholine esterase which is there, okay, I'll just write down acetylcholine esterase which is there. This is called as true esterase. This is called as true esterase, and this is present in the synapse. Now you are having something called as butyrylcholine esterase. Butyrylcholine esterase. This is called as pseudoesterase. This can be your 2-mark question. This is called as your pseudoesterase, and this pseudoesterase which is there is present in the liver, is present in the plasma. Okay, so you're mainly having, if you talk about the anticholinesterase, you're mainly having two. One is acetylcholinesterase, other one is going to be your butyrylcholinesterase. Acetylcholinesterase which is there, it's called as true cholinesterase, but whereas if I talk about the pseudocholinesterase, this is, if I talk about butyrylcholinesterase, is going to be in the part of your pseudocholinesterase. I hope it is clear till here. I hope the transmission of cholinergic activity is clear over here. Now, we are going to discuss about the cholinergic receptor. This is a very important topic. 100% you can expect 2 or 5 mark questions. Mainly 2 mark questions you can get from this topic. That what are the various or classify the cholinergic receptors. Okay, as discussed over here, right? See, various cholinergic receptors are there. Acetylcholine will be released. Now, where this acetylcholine, see, I told you this cholinergic drug is going to activate the parasympathetic activity. So what are the parasympathetic activities that we have discussed earlier? For example, it can decrease the heart rate, it will increase the GI secretion, it will increase the urine secretion, right? So how is that mechanism is going to happen? How is the heartbeat going to lower down? How is the gastric secretion going to be increased? That is based on the cholinergic receptor. Now, one very beautiful question is there related to this cholinergic receptor. Okay, this question will make your concept very clear. Now, there's only one receptor is cholinergic receptors we have learned about, right? But to tell me, one cholinergic receptor is there, how can it have more than one function? For example, cholinergic receptor is there, which is there in the heart. It's going to decrease, or it's going to, if you talk about decrease the contraction of the heart, or it's going to decrease the blood pressure, right? This is what cholinergic activity in the heart, cardiovascular activity if you talk about, is going to decrease the ventricular contraction. That's why, see, when I'm telling you about heart rate and BP less, that means I'm decreasing the S node and AV node activity, right? Similarly, if we talk about GI, if I talk about eye, right? If we talk about eye, pupil, it's going to dilate the pupil. Is going to cause contraction of the smooth muscle. At the same time, same drug, but different receptors. See, these are cholinergic receptors are there, but different, same, the product which is there, acetylcholine is same, but still you are going to have various functions. For example, somewhere it is going to be smooth muscle contraction, but where somewhere else you are going to have smooth muscle dilation. How is that possible? That is because the cholinergic receptors which are there, these are the G protein couple receptors. These which are there, cholinergic receptors which are there, these are the G protein couple receptors. Okay, this concept detailing and beautifully I have explained in general pharmacology. If you have not seen, please go through and have a view on what is G protein couple receptor. Okay, fine. I hope you have understood. Now, mainly my intention for you to tell you is that one cholinergic, the drug is same, acetylcholine, but it's going to have various functions. Why and how? This is because of the G protein couple receptor. That's the answer for this question. Now, let us try to understand. We are classifying your cholinergic receptor into muscarinic receptors and your nicotinic receptors. Okay. So when I talk about muscarinic receptor, there are five subtypes: M1, M2, N3, M4, and M5. Whereas if I talk about the nicotinic receptors, there's NN and NM. There's nothing but your autonomic ganglia. This is going to act on autonomic ganglia, and whereas NM, which is there, it is specifically going to be there in the neuromuscular junction. This is going to be there in the neuromuscular junction. Let us try to understand about the muscarinic receptors a bit. Okay, about it. So if I talk about the M1 receptors, over here, this M1 receptor, this is about the location. Where is this M1 receptor present? It is mainly present in the gastric glands and in the CNS, the central nervous system. If I talk about M2, a very important question, okay, you have to always remember this. M2 which is there, this is going to be present in the heart. This is going to be present in the heart. Now if I talk about the M3 receptors which are there, they are mainly present in the smooth muscles and the exocrine glands like salivary glands or other exocrine glands which are going to be there. And then M4 and M5 which is there is going to be present mainly in the CNS or central nervous system. Now as I told you that your parasympathetic activity means one is going to be a cardiovascular, other one is going to be GI. Okay, it's going to mainly affect the cholinergic system which is there. It's going to mainly affect two things. Okay, one is the gastric or the GI tract, other one is the heart. And then you're going to have smooth muscle and CNS, that's all secondary. But primary thing or primary focus which you have to understand is on the gastric secretions and in the M2, that's nothing but the heart. Okay, I hope it is clear. Now just try to understand. You understood the location, right? Now understood the location, you understood the drug. That this drug is going to acetylcholine which is there, or acetylcholine precursor which is there. This is going to go and bind with this various receptors. Now when it binds to various receptors, for example, if it goes and binds to M1, what is going to happen is going to increase, like G protein couple receptor. I think if concept is clear, then you understand this very better. Okay, it will increase the IP3 level, it will increase the glycerol level, right? So because of this, what is going to happen? There is going to be smooth muscle contraction. There is going to be smooth muscle contraction because of the calcium flow. Because of the calcium flow, there is going to be smooth muscle contraction. And as I told you, M1 is present in the CNS also, right? So it is going to enhance or going to promote learning and memory. It's going to promote learning and memory. Is it clear? Now when I talk to you about over here, about the M3 which is there, is mainly present in the exocrine glands, right? Or the smooth muscles which is there. So smooth muscle obviously is going to cause contraction here. Smooth muscles which is there is going to cause contraction. But whereas if I talk about your exocrine gland, it is going to increase the secretion. That's why I said you, when you are in parasympathetic activity, when you are relaxed, your saliva secretions will increase. Okay, the saliva secretions we talk about, or GI secretions which we talk about, is going to increase. Now how is this going to increase? When your IP3 level and DAG levels are going to be elevated. This is what is the mechanism of G protein coupled receptor. Okay, that's why I had that time also I told you G protein coupled receptor is a very important topic, and as we go in the flow, I will be telling you more about this G protein coupled receptor. I think now it is a bit more clear. Okay, now next if I talk about the M2, over here, this M2 receptor is mainly present in the heart. So what is this? See, here the mechanism is slightly different. Here we were going to increase the IP3 level and DAG level. Here we are going to decrease the cyclic AMP level. Now we are decreasing the cyclic AMP level. That means the calcium ion influx is going to be decreased. So when the calcium ion decrease is, when calcium ion's influx is decreased, then what is going to happen? The smooth muscles which are there, or the cardiac muscles are there, they will not be able to contract. So this is going to lead to decrease in the ventricular. Okay, if you talk about the atrial and the ventricular contraction is going to be decreased. Okay, because calcium ions are not there. Why calcium ions are not there? Because cyclic AMP is less. Now why cyclic AMP is less? Because when this acetylcholine goes and binds to M2, it's going to decrease the cyclic AMP level, because of which the potassium ions are going to be open. And after that, because of potassium ion will increase, so what will happen? Calcium ion will decrease. So when calcium ion will decrease, what will happen? The contraction will not happen. We'll talk about the SA node and the AV node activity is going to decrease. Now are you understanding? In M1 and M3, when we're discussing what IP3 and DHA is going to increase and smooth muscle contraction is going to happen. But similarly, if we talk about M2, what is going to happen? The smooth muscle dilation is going to happen, or the contraction will not take place. Here the calcium ions are increasing, here the calcium ions are decreasing. So this contrast is there, right? Now why is this contrast there? Same drug, same receptors, but the thing over here is, this is G-protein couple receptor. This is G-protein couple receptor. The secondary intracellular messengers, that means this IP3 and the cyclic AMP, these are different. That's why same drug having multiple activity. I hope multiple and in contrast activity. So I hope it is clear to you. Okay, fine. Now next is going to be the M4 and M5. This M4 and M5 which is there, it's mainly present in your central nervous system, and these are going to open the ion channels and they're going to cause depolarization. Depolarization means relax. They're going to relax the smooth muscle. They all are responsible for relaxing the smooth muscle. Similarly, if we talk about your nicotinic receptors, you're having this NN. We'll again see when I will be again explaining about this more in detail. Okay, this is just here to understand what are the various receptors which are available and their activity and their location. Three things that you remember: receptors, classification of receptors, types of receptors, where location of the receptor, and what is the function. Like for example, when acetylcholine goes and binds to the receptor, what effect is going to come? That is what you're supposed to remember in this particular flow chart. Okay. Next, I told you about nicotinic receptors. We're having autonomic ganglia. This NN which is there is going to be mainly present in the autonomic ganglia. Okay. And then you are going to have even these receptors which are there. They're going to be present in the adrenaline medulla. It's going to be present in the adrenal medulla. Similarly, if we talk about NM, in NM, I'll detail discuss when I'm discussing about myasthenia gravis, okay, or when I'm explaining you about the skeletal muscle relaxants, when I'm going to come in that, like D-tubercular and all these things, that time maybe a little more elaborate on this NM. That is nothing but these are going to be present in the neuromuscular junction. So I hope it is clear for today. We have mainly discussed about, we have started the autonomic nervous system pharmacology. In that I told you in brief what is adrenergic, non-adrenergic, cholinergic, anti-adrenergic, all these things I have mentioned. Now, I told you about the cholinergic transmission. First, we are focusing on the cholinergic drugs, or the cholinergic classification or cholinergic transmission. And in that, I told you about acetylcholine, which is the major neurotransmitter in cholinergic transmission, right? So I told you how is it synthesized, what enzymes are responsible for degrading it, how we can increase the acetylcholine concentration, because cholinergic drugs are going to activate the acetylcholine, right, or activate the parasympathetic activity. Then I told you about various receptors, or what kind of receptors are going to be there in this cholinergic receptors, and then we discussed how the binding of acetylcholine with these receptors is going to have multiple actions and multiple and different action in the sense. Okay, so I hope it is clear for today. Thank you for everyone, like you're watching and supporting us. Okay, soon the notes also will be available in the Telegram channel for this particular chapter. Now we are trying to speed up the lectures and everything. You will be getting more frequent lectures. Okay, so thank you for today. In the next class, we'll be understanding about the classification of the cholinergic drug and pharmacology of acetylcholine, which is a very, very important. That is a 10-mark question in your examination. Thank you for everyone.